Okay, so that's going to be episode 2. And the last episode, we created the basic makefile and directory structure such that we can actually run the tests and do a TDD style development. So let's get going. And first off, I've noticed that there was a few things that I needed to clean up. So this, and also there is a handy way to reference whatever is here. You can reference it with that special makefile variable $at. Not a, but at. Cool. Let's run this, make sure that it still works. And it still works. Okay, so let's continue with our test. Do I want to reread? Yes, I want to reread it. Cool. Let's make this pass for my OCG. Well, I don't have OCG. I'm joking. And right, so that was here. Cool. That works. That works. So I guess right now we are gonna need to sort of like create a game. Create game. Actually, let's call it game create. That will return a game a T structure, and that will work something like that. And we will probably want to expect that this game isn't equal to null. So a null pointer, because that is C++. Right, undeclared variable game. Oh yes, obviously, and you need to do something like this. So, well, at that point, we can try to compile, but that's obviously not going to work because there isn't such a thing as a game T structure. So, let's go and create that structure. What we're gonna do, we're gonna put our test, not our test, but our normal source code file into the trusty SRC folder, right? That pretty much every project has, and we are going to create the risk.h file. I believe you can do pragma once. I think it's like this, pragma once, yeah, just to make sure that flies only gets included once. And then we can create our structure, our struct. So let's make a type of type struct, and that's going to be a game T and game T. Okay, so we should probably include this. So we're going to need to use the extern C to tell the compiler, because that's going to be compiled with a C++, but to tell the compiler that this is actually a C file. And then risk.h. All right, so risk.h, file not found. Cool. Why isn't it found? It is not found because we actually need to add that to the C flags. And so these C flags, we are going to add the SRC folder in it. That should do the trick. And it kind of does the trick. It's complaining about an empty struct, which is okay, and then after it's complaining about a undeclared identifier game create. So let's declare this. Let's make so the game create, it's going to return a game T, and that's going to be game create. Whoops. There you go. At that point, I think we can run the compilation, and it compiles, but you get a runtime error because it cannot find the symbol. because we haven't actually implemented this. So we need to create the risk C file where we're going to actually put our stuff. So let's start by include the risk header, right? And then we'll actually create this function, game T, and I think is game create. Okay. And we will start with allocating a game structure. So we're going to calloc, and we only want one, and it's going to be size of the game T structure. Game T, yes. Okay. So if we couldn't allocate any more memory, so if game is null, basically, well, then we are going to print an error to standard error, std error, and call that game create failed to create game. Failed to create game. Yeah, that's fine. It's failed to allocate in reality, but yeah, whatever. Return null if that's the case. Otherwise, we can just return our game structure. That should do the trick. No, it doesn't do the trick because we're going to have to add a bit more work to this in the makefile. So I'm going to try to remember how we do that. I want to do something that will be generic enough. And you'll see that pattern used in makefiles. I don't know if it's quite a lot, but you will definitely see this. So at that point, what we need to do here when we compile this, we will need to give it object files that is going to be compiled by the compiler for that risk.c file. So we need to define a couple of things. We need to define our sources. Actually, let's make a source dir. Let's make a source dir, which is going to be src, right? I also wanted to change this as well to be consistent, like a bin dir, and I also use that here, bin dir. Okay. And we will then collect all of our source files. So that's going to be srcs. We are going to look for all of the files. So we're going to use a wildcard again and say, hey, everything that is in the bin, the src dir, and ends with a .c file. You're gonna create a list of that and that's what the src is going to represent. We also need from these srcs to create object files, which will be linked against the executable. Like in this case, it's going to be the test executable. At that point, we don't yet have an executable, but it's perfectly fine. So there is a function in makefiles called parstubst. What a horrible name! Which basically takes a pattern. So every file that starts with a %c is going to, we're going to generate a .o. Well, not really a generate, but that's going to create a string. But it will replace everything that is before. It will replace the .c by the .o, and that is going to come from the list of files that are in $srcs. Right, so at that point we've got those objects. And we need to provide those objects to the tests executable. So if I'm not wrong, I think you do this, and instead, and then you pass $obj here. We'll see if it works. I'm not quite sure, but I think that's how it works. Right. Let's run actually the test. It's gonna fail, but we'll have a. Okay, that's not what I thought it would do. And $obj. OBJs. SRCs. Okay, let's debug that, because I would have expected like to have some in here. I would have expected to have something like test, I can't. The object file, basically, like risk, a risk.o file. So there's a make, like, let's use our info debug thing, debug function, and objs is equal to $objs Okay, so it is empty, right? Why is that empty? I have no clue. So let's debug src. What is in src? Okay, src risk.c. Maybe I didn't spell that right. Probably didn't spell that right. Make file and okay. And it's but subst. Yeah, that wasn't right. So, yeah, okay. That works now. And as you can see, it's put this in here, which is good, I guess. Except that this doesn't actually do anything because we haven't really built our so it is doing lang minus minus c.o. Okay, that's interesting. It looks like it's oh yeah, it's actually done them. It's actually compiled them. Okay, well that's good. It's actually quite smart. And so that's something we're gonna need to clean as well. Okay, and all right. I think this is fine. So it's compiled the object. Okay, cool. Let's just run make clean, making sure that it does what it does. If I refresh, yeah, okay, it has actually cleaned the object files as well. Cool. So now we have a test failure. Like, to be fair, I was expecting this not to fail. So there is probably something funny going on. Oh, we expect equal. Yeah, no, what if we want this to not equal. And brilliant. There you go. Now we can compile our stuff. I think to get rid of this error, I need to do also add my src folder to the c include path, and and SRC as well here. And let's update Dirolv. Okay. And I believe now, so I restart my LSP. Okay. He's not found it. Whatever. We can keep going. Excellent. Cool. So, so that create game function, that's great. But in a game, you know, we need some players. How many players do we have in a Risk game? In a game of Risk, well, you have a maximum of 6 players. So I guess we can define this. So let's do a define. I thought I had a shortcut to do that in Emacs. There is, but I don't remember. So max players is going to be a 6. And I guess we want this to be a uint 8 T. Just, you know, just trying to be a good citizen here and like make the smallest possible executable or memory. I mean, you know. So we are gonna need to store this how many player, because when we create a game we can play like 3, 4, 5 up to 6 players, but like from 2 to 6 players. Doesn't make sense to play alone, to be fair. So we need to store that somewhere, and let's make a uint 8. If I can type uint 8 player count. Cool. And so let's go back to our test now. I guess I could close this now and go to the where is risk.c src risk.c. There you go. I guess here I want the player count to be 0. I want to make sure that when I start with an empty game, expect equal game, and then player count to equal 0. And our test pass, so that's good. Why does it pass? Because CLOC actually like 0 out the memory, the entire memory. So this is definitely going to point to a 0, which is, you know, quite good, but doesn't demonstrate much for now. So once we've got a game, we need to add a player. So what do we need to add a player? Like on the board, they're represented by little pawns. So you've got different types of pawns, like armies. You've got infantry, cavalry, artillery, and they have different colors. Like, where are the colors? 6 set of armies, each different colors. Yeah, I guess I need to look for color. Yeah. Is there the list of color? I think I remember the list of color by heart. So we need an enum to store those colors. So let's do that in our risk.h. Let's make this type def. That's going to be an enum, and that's going to be color, player color. And okay. Okay, and so we are going to have black always we're gonna have red. Do you add? I'm gonna get confused. No, I think it's this. Yeah, black, red. No, I think it's definitely expecting something like this, perhaps. Inmum, no, enum. Yeah, that'll do it. Yeah, there you go. There you go. Black, red, green, pink, yellow, and red, pink, yellow, and then white, I guess? I don't remember. Let's ask Google. Google Risk board game colors. Yeah, green, pink, oh, blue. Yeah, that's not white, that's blue. Okay. That looks good. So that's going to be 0, 1, etc., etc. So, so we need to create a player. So what is the API going to look like? So maybe something like game add player, and you'd pass in the game and you'd pass in the color. Let's say, for example, black. I think that might work, and that would return a player T player, and that would be a pointer, obviously. Okay, so let's run the test. That's definitely not going to work because like such structures don't exist, but that's the whole point of TDD. It's like, hey, what is the thing that you need to do next? So the thing that we need to do next is obviously implement that custom player struct, which is going to be a player T, this, and player T. And we are going to have a player color, which is going to be a color, actually. Yeah. Cool. Like this. Should be good to go. Let's run that. Good. So now it's telling us that we don't have such a thing as a game add player function. So let's create that game add player function. Okay, that's going to take in a player color, which is going to be the color, and a game T pointer to a game, and that is going to return a player T pointer. Cool. Now let's go run the test. All right, cool. So we got a bit further. Let's actually implement that function now. All right, so that's going to be more or less the same thing. CLOP1, but we want a player T, right? That's going to be our player T pointer to a player. Obviously, we need to check, yeah, have we managed to create our player? And if not, print F to standard error, and that's going to be game adds player failed to create the player. Cool. And then here you return null. All right, and then here you return your player. Oh, but you also want to set its color. Okay. We could actually do something like expect, again, not expect player dot color, to equal black. Of course, here we need to... Actually, let's not do anything. Cool, that works. Let's add now another player. A blue player. What is wrong with you? Blue? Yeah. Is that how you spell blue in English? Or did I just... No. Yeah, that's not how you spell blue in English. Let me rename this to just blue. Excellent. Yeah, good blue. And then here, blue. Let's run our test and see what it says. No, it's... Oh, yes. Okay. I guess that's going to be black player. And that's going to be blue player. Okay, so let's actually fix the variables and the blue player. All right. And you can see that its color is 5. Okay, well, that's normal because we are not setting the color on the player in the initialization. So let's set it and then color. Yes. Let's now rerun our test. And this passes. Wonderful. So let's go on and keep adding another player. Let me reopen the C file. Let's do them in order. So after green, okay, so we need the red, and this is going to be the red player. And it should have a color red. That works. And let's do this, and let's remove red with pink. That didn't do what I thought it'd do. All right, red. Okay, with pink. Sweet. Okay, that works as well. And let's replace pink with a yellow. Okay. And I guess let's take pink. And here we need to... Okay, I think at this point... How many players? 1, 2, 3, 4, and 5. So which one is missing? Black, blue, red, pink, yellow. Black, blue, red, pink, yellow. And oh, we're missing the green. Mr. Green. Okay, let's add Mr. Green. And let's replace pink with green. Great. Let's run our tests. Everything passes. That's amazing. And here, let's say we add the green player again. So that should be a non-valid, an invalid player. Yeah, invalid player. And so that should return null. Yeah. And let's make sure that is a null pointer. Let's run the test, and it is not a null pointer, unfortunately. Why? Because, well, simply we haven't done our due diligence in the game add player that you can't add more player. And also, in fact, we forgot to add another check as well here for the game, and player count here should have been incremented. So that is player count to equal 1. And here that should equal 2, 3, 4, 5, and 6. Let's rerun this. Oh, yeah. I type in, and let's replace, what's the typo? UNR with UNT. Okay. All right. Well, it is not being incremented as well. So when we add the player color, we should also increment the player count. And that should do the trick. Yeah, all our tests pass, and we're back to square one, where we want to test that you can add more players than the game allows for it. So we need to have a condition here. If game dot player count is, so that's going to be 6, is inferior to, is greater or equal to max player, then we should print an error, game player, max number of players reached, or cannot add more players than, let's do person EU, and \n actually as well, which I forgot. \n, let's add a little dot at the end. And this is going to be max player. And of course, we return null. Let's run those tests again. Okay, so that isn't quite right. That should be this. And that's great. And we can see our message being printed. So that's cool. I guess we could. Do we need to do anything else? I guess, yeah, we could also store those players in the game struct as well. So how are we going to do this? What is this stuff _IO? I don't understand. I think it's std_int. No, it's std_lib, I guess. Yeah. Cool. My LSP is doing something a bit funny. All right. Okay. What else? So we said we were going to add we need to store those players on the game struct as well. So we're going to make an array of players. Actually, let's make this a player t pointer. That's going to be players. Do I want a pointer to pointer, or just I want a pointer? That's interesting, I guess. Because if you make it a player, you can always do pointer arithmetics. Yeah, let's do that. Let's just use like a simple pointer rather than a pointer to pointer to make things easy. So we need to also allocate, when in the game create, we need to allocate the space for that. So game, so game. So that's going to slightly change our game at player function as well. But not to worry, I have a plan for that. So game player is going to see alloc. So we're going to calloc. We are going to alloc max player and the size of player t. Cool. So this means, so we can actually verify here that as well here, dot not equal game dot, oh, actually that is going to be equal a null pointer. Oh, I guess no. Not equal game, and that's going to be players. Cool, that still works. However, now instead of, because we've already done the application here in the game create stuff function, so now we don't really need per se to allocate those. But what we want to do instead is get the player from the player array, well, from the player's pointer in the game. So the game got players, and then we are going to access it via the player count. Right, so when there's no player, this is if, so this effectively allocates an array, right? So we're going to grab the player from there, and that actually needs to be this. We dereference that, and we've got the player, and then so that player is going to be this, and then you return the player, right? Is this how it's going to work? I'm not sure actually. So here we've got an error. I don't know why LSP UI doc mode. It's not showing me the error. Okay, well, never mind. Actually, we could see it somewhere else. So where is this stuff? Player T, yeah, okay, cool. So the player T expression invalid, take the address with, right, so yeah. So we need to take the address. We need to take the address, basically, rather than dereferencing it this way. And we've got that player, and then we do this, we assign its color, and then we return the player. I guess we don't need to do that check anymore, but we do need to do it here. So let's do this in like a somewhat orderly manner. Failed to create players. Failed to create players. Right. So that sounds good. Okay, let's rerun the test. And our little refactor works, which I am pretty happy about. I think we can call it a day for this episode. So let's commit this. Let's commit everything in there as well. And let's do this. Yeah, let's commit. And let's do, yeah, implemented, add game, add player, functionality, function. Yeah, that's good enough for me. All right. So I'll leave it here for this episode, and I will see you later.